Hello friends, in this short lecture series, we are going to learn about Jacobian. Recently I met a boy whose name was Sarthak. He was such an intelligent guy and he asked me about the Jacobian. At first I laughed and I replied that you are just a young boy, wait for some years, you will get to know about this. But he was too eager to know and he just said like, can't you describe this in a simple way like 3B 1B does? Then I realized that I have met one more fan of 3B 1B, so I tried to explain this in the simplest way possible. So here we start. Hey Sarthak, consider you want to buy some notebooks and pens from a stationery shop. And let us consider that the cost of 3 notebooks is 30 rupees, cost of 5 pens is 25 rupees. Then tell me the cost of 5 notebooks and 7 pens. So you will pay 85 rupees for 5 notebook and 7 pens. But how did you get this answer? So basically this is 50 for 5 notebooks and 35 rupees for 7 pens. But can you show me the calculations you used? Basically the cost of 3 notebooks is 30 rupees. The cost of 1 notebook is 30 by 3 rupees. Cost of 5 notebooks is 30 by 3 into 5, which is 50 rupees. Similarly, on the same base, the cost of 7 pens is 35 rupees. That is absolutely fine. Let us generalize this formula as a cost of p objects is equal to the cost of n objects by n into p. The general expression of this cost function is like this. So I guess this is very fundamental and clear to understand. Now, what if I plot these curves individually, like I want to calculate the cost only for the notebooks? So you will see a linear graph. If I plot this collectively, so this will look like this, in which on one axis you can see 0 to 10 pence towards your right, and towards absolute left along the vertical axis you can see the total cost. Now look at the plane which is representing cost versus handbook. So first from 0 I can move to 5 handbooks, and then look at the plane of cost versus pen on which I can move to the point of 7 pens. So overall this is the point of 5 handbooks and 7 pens. Yes, this is easy my dear friend, but wait, world is not that linear. Not all the curves in this world are like those planes. Some are like this, with curves, twists and everything. Then imagine, how can you explain this or understand this curve? About the difficulty, well yes, but actually no. Let me first crack a joke about it. Here is a boy who says, hello Sachin and Sarthak, I am a flat earther because whatever piece of earth I look seems flat. Now, this other beautiful creature says, I am a flat sapphirer by the same reason. Ha ha ha, this is hilarious. A flat sapphire. Dear Sarthak, this is a joke. You laughed at them because their opinion about a bigger picture is wrong. But they are very much confident in their limited scale of observation. The object looks curved as a whole but seems flat when you observe a very small part of it. This is not exactly flat but approximately flat. You can also measure the distance between 2 points by measuring and adding many small flat distances between them. Mind my words. Now we are going to behave like a flat curver and look at this problem again. We will look at the smallest part of this 3D curve and we'll do the same formulation. The cost of del n notebooks is del c rupees. Cost of one notebook is del c by del n rupees. Cost of dn notebooks is del c by del n into dn rupees. This is normal unitary method but at a smaller scale. And finally, the overall cost will be because of this n and p. But the main consideration is that this is very small. So there is small change in something n, there is small change in something p. So overall we can find out what is the change in the value of this cost function something c. Let us understand it further. The formulation we have chosen is only for the small change. What does this mean change? Overall we are at this point of 3 handbook and 5 pens, and from 3 handbooks we reach to 5 handbook and 5 pen, and after that we change the number of pens and reach from 5 handbook 5 pens to 5 handbook 7 pens. So overall, at the beginning of this question, we know the cost of 3 handbook and 5 pens. When we have changed the number of handbooks from 3 to 5 and pens from 5 to 7, with this, what is the change in the cost? We are finding this change here. So overall, when I know the cost of 3 handbook and 5 pens, I can add this change in cost with this function, and overall I can get the cost of 5 handbook and 7 pens. Isn't it simple? But how to measure this quantity del C by del N? Basically this is partial derivative. For now, just think of it as a quantity which tells you about the change in C with respect to very small change. There is a list of rules and formulae on how this behaves and derived. But you said you have seen 3B 1B videos, so you can recheck his calculus series, or you can also post your queries in the comment section here. Now let us move one step forward towards the Jacobian. Now my dear friend, imagine you add one more item X in your shopping list. Then the change in the cost because of material NP and X will be like this. Obviously it is hard to imagine or plot this in a 3D restricted opinions, but it still works. And we can also think of a setup where we require some other quantities like what is the total weight of this material, what is the total volume of this material, and the cost which we have already calculated rather than their quantities. So overall we can construct 3 equations like this. For example, in the case of weight, the weight of 3 notebooks and 5 pens is something like this. Now tell me the weight of 5 notebooks and 7 pens. So a similar question can be framed and asked. So that's why these 3 equations can be constructed in this way. Finally, you have reached to a point where you are very close to understanding Jacobian. So now pay attention and be careful about each and every word. Finally, you consider that you want to send this material to a friend and the delivery company is interested in the weight, volume and cost of the package only. Overall, you prepared a package containing N notebooks, P pens and X items whose weight is considered 700 grams, occupies 600 centimeter cube and costs around 200 rupees in total. Your shopping list is the same, but you changed it from one set of independent variables to another set of independent variables. These equations can also be written in the form of a matrix. So this is the construct through which you can change one set of independent variables to another set of independent variables. But there is a slight twist in the story. The delivery company charges you on the basis of the number obtained from the multi-dimensional volume of dW, dV and dC. This may sound absurd, but like you can imagine, if its weight is more, then they will charge you more. If its volume is more, then again they will charge you more. And the third thing is, if it costs more, then for an insurance you need to pay them more. So you know this multidimensional volume, but consider this is your regular job and you do this every day, but you don't want to calculate its weight, volume and cost whenever you send this to somebody. Then you need some another formula through which, just by knowing the number of notebooks, pens and X items, you can calculate this quantity. So overall you need a multi-dimensional volume in a different space. So how could you change this quantity? Now the determinant of this matrix gives the factor by which this multi-dimensional volume changes from one set of variable to another set of variables. And this magical quantity is your Jacobian. For understanding more about determinant, Watch 3B1B's linear algebra series. Overall, whatever the determinant of a matrix does in linear algebra, the same thing Jacobian does at a very small scale for non-linear cases. Wow, I have seen that linear algebra series. I can correlate. That's very nice. So in a nutshell, we started with buying notebooks and pens and calculated its cost using unitary method. Later, we went for linear to curved things and looked at much smaller case. So here we introduced differentiation or partial differentiation, and then we extended our number of equations from 1 to 3 and also extended the number of variables from 2 to 3. Finally, we used matrix formulation and found the factor determining the change in multidimensional volume on changing from one set of variables to another set of variables using Jacobian. It's okay, Sarthak, and also thanks to you because wait a minute. Have I introduced you to this guy Sarthak? Sarthak is a knowledge hungry person sitting inside me who used to ask me the easiest explanations for the most difficult questions. Sarthak is a word from Indian language Hindi and it literally means being meaningful. At somewhere the theme of this video is inspired from the great Indian mathematician Bhaskara too, who used to talk to his daughter and discuss mathematical problems with her. Thanks for watching. If you like this video, then please share this, like this, and also don't forget to subscribe to my channel so that whenever I teach something to my friend Sarthak, you can also be a part of it. Take care and have a very good day.